Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to practice questions from ICSE Class 10 Maths Chapter 9, Matrices Exercise 9D. We have studied all the concepts about matrices. We have studied scalar multiplication of matrices and also matrix multiplication in our previous classes. If you haven't watched that video, go watch them first. We'll practice more questions from exercise 9D together. Are you all ready? Yes, we'll solve together. Hope you all remember the concepts we have studied in the previous classes. Let's start with an example. This is a question that was asked for board exam 2021. If A is equal to 20 minus 17, then A square is, we have four options. First, 40149. Second, 40 minus 949. Third, 40949. And the fourth, 19 minus 948. Options are somewhat similar, right? Okay, let's find. Here we have A is equal to 20 minus 17. How to find A square? What is A square? A square is matrix A into matrix A. Yes, you remember? Okay, here matrix A is 20 minus 17. We are multiplying this again with A. 20 minus 17. Matrix multiplication is possible only if the number of columns in the first matrix is equal to the number of rows in the second matrix. We have to check the order of the matrix. This is a 2 by 2 matrix. Number of rows is equal to 2. Number of columns is equal to 2. This is again a 2 by 2 matrix. Number of rows 2. Number of columns 2. Here the number of columns of first matrix and the number of rows of second matrix are equal. Therefore, matrix multiplication can be done. Now, to find the elements of A square, we'll be getting a new matrix, product matrix, which is of order 2 by 2. We have studied if you are taking an M by N matrix and an N by P matrix, multiplying these two matrices will give us a matrix of order M by P. In this case, M is equal to 2 and P is also equal to 2. Okay. To get the first element, what to do? We have to consider the first row of the first matrix and the first column of second matrix. This is the first row. This is the first column of second matrix. Now take the first elements of these two matrices and multiply them. Here the first element of first row is 2. First element of the first column is 2. 2 into 2, 4 plus. Next, we have to take the second element of first row and the second element of first column of second matrix. 0 into minus 1, which is 0. From this, we can get the first element of the product matrix. Next, to get the second element, we have to consider the first row of the first matrix and the second column of the second matrix. Here we have first element 2. Here the first element of second column is 0. 2 into 0 is 0 plus. Next, considering the second element of first row and the second element of second column. 0 into 7, that is again 0. To get the third element, we have to take the second row and the first column. Here in the second row, we have minus 1 as the first element and the first element of the first column of second matrix is 2. Minus 1 into 2, minus 2 plus. Here the second elements are 7 and minus 1. That is 7 into minus 1, minus 7. To get the fourth element, we have to consider the second row of this first matrix and the second column of second matrix. Minus 1 into 0 is 0. 7 into 7, 49 plus 49. From this, we will be getting what the elements of A square is. Just adding. Here we have 4 and 0. 4 plus 0 is 4. To get the second element, 0 plus 0, 0. Third element, minus 2 plus minus 7, that is minus 2 minus 7, which is minus 9. Fourth, 0 plus 49. 0 plus 49 is 49. Now check the options. Do we have this option? First option is 4, 0, 1 and 49. Here we have minus 9. In the second, B, we have 4, 0, minus 9, 49. So B is the correct answer. Got it? We are just finding A square. Once you find A square, we can match with the options given. You will get the final answer. Let us now move to problems from exercise 9D. Here we have the first question. Find x and y if 3 minus 2 minus 1, 4 into 2x, 1 plus 2 minus 4, 5 is equal to 4 matrix 2y. We have studied matrix multiplication. We have studied the scalar into a matrix multiplication. Yes, you remember? Also, we have studied addition and subtraction of matrices. All these concepts can be put together to solve this question. Here, we have 3 minus 2 minus 1, 4 into 2x, 1. First, we'll find this part. Okay, we'll multiply these two matrices. Is the matrix multiplication possible? Here we have 2 rows and 2 columns. Order of matrix is 2 by 2. Okay, what about this? Here we have 2 rows but only a single column. This is a 2 by 1 matrix. A matrix with a single column, what do we call? Column matrix. This is a column matrix. Okay, so is the matrix multiplication possible? Number of columns from the first matrix should be equal to number of rows in the second matrix. Here the number of columns is 2 and here the number of rows is 2, which means matrix multiplication is possible. We will be getting a product matrix whose order is m by p. Here m is 2 and p is 1. That is number of rows of the first matrix by number of columns of the second matrix. We will be getting a 2 by 1 matrix. Now to find the elements of this 2 by 1 matrix. Here considering the first row and this column. 3 into 2x. 3 into 2x plus minus 2 into 1. Minus 2 into 1. This is the first element. Then to get second element, we have to consider the second row and this column. Minus 1 into 2x plus 4 into 1. Okay, then what are the elements? Elements of the 2 by 1 matrix. 3 into 2x. 3 into 2x is 6x. And here we have minus 2 into 1, which is minus 2. 6x minus 2 is the first element. Second element, minus 1 into 2x is minus 2x. 4 into 1 is 4. Minus 2x plus 4. Okay. So we got this part. Now we are adding this to 2 into matrix minus 4, 5. That is 6x minus 2 minus 2x plus 4. This matrix plus 2 into minus 4, 5 is equal to 4 into 2y. Okay. Now we are going to multiply the elements of this matrix with 2 and the elements of this matrix with 4. What do we get? We already have x minus 2 minus 2x plus 4 plus 2 into minus 4. 2 into minus 4 is minus 8. 2 into 5 is 10. Minus 8 and 10 are the element of this matrix. Is equal to, multiply 4 with the elements of this matrix. 4 into 2, 8. 4 into y, 4y. Okay. Now, considering the corresponding elements, we can add these two to get this. Adding these two will be equal to 8. Adding this two will be equal to 4y. That is, adding the matrices, we get 6x minus 2 plus minus 8. That is minus 8. Second, we have minus 2x plus 4 plus 10. That is equal to 8, 4y. Okay. This is the first element of this matrix. This is the first element of this matrix. They should be equal. Yes. That is 6x minus 2 minus 8 is minus 10. Minus 10 is equal to 8. Similarly, considering the second elements, here we have minus 2x plus 4 plus 10. Minus 2x plus 14 is equal to 4y. Minus 2x plus 14 is equal to 4y. To find y, first we need to find x. We can find x from this equation. Yes, we can find the value of x from this equation. That is 6x minus 10 is equal to 8. Taking this minus 10 to the opposite side, we get 6x is equal to 8 plus 10. That is 6x is equal to 8 plus 10 is 18. And x is equal to 18 divided by 6, which is 3. Value of x is equal to 3. Now from this value of x, we can substitute here and find the value of y. We have minus 2x, minus 2 into 3 plus 14 is equal to 4 into y. Minus 2 into 3 is minus 6. Minus 6 plus 14 is equal to 4y. Or 4y is equal to minus 6 plus 14, that is 8. Which means y is equal to 8 by 4, that is 2. Value of x is equal to 3 and value of y is equal to 2. Clear? Here we have used both the matrix multiplication concept and scalar into matrix concept, plus the first class we studied the addition subtraction of matrices. Even that concept is used here. Okay. Next, problem 2, question 3 of exercise 9D. If xy into xy is equal to 25 and minus xy 2xy is equal to minus 2, find x and y. Here, this is a 1 by 2 matrix. Number of rows is 1 and number of columns is equal to 2. What about this? Here we have 2 rows and 1 column. This is a 2 by 1 matrix. What about this? Here, this is a 1 by 1 matrix. 1 row and 1 column. Here again, this is a 1 by 2 matrix. This is a 2 by 1 matrix and this is a 1 by 1 matrix. Okay. We need to find x and y. There are two conditions. The first question is xy belongs to w whole numbers. Second, xy belongs to integers. Okay, let's start. First, we have matrix xy into matrix xy is equal to 25. This is a row matrix and this is a column matrix. You remember what row matrix and column matrix are? A matrix in which there is only a single row. This is a matrix containing only a single row. This is a row matrix. A matrix containing only a single column is a column matrix. Okay, we'll multiply these two matrices. Here, we know this is 1 by 2 matrix and this is 2 by 1 matrix. Then what will be the product matrix? Order of the product matrix. Check if the matrix multiplication is possible. Here, the number of columns of the first matrix is equal to the number of rows of second matrix. Here, the number of columns is 2, number of rows is 2. They are equal. Then, we will be getting a product matrix of order 1 by 1, m by p. Here, m is 1 and p is 1. To get the elements, considering the row and this column, first element here it is x and here it is x. X into x, x square, plus the second elements. Here it is y, here again it is y. Y into y is y square. That is equal to 25. Okay, these two matrices are equal. They are of the same order. Then the corresponding elements are also equal. Which means x square plus y square will be equal to 25. This is our first equation. Okay. First equation is x square plus y square is equal to 25. When you solve this, you will be getting another equation. Equating both these equations will get x and y. Here we have minus x, y into matrix 2x, y is equal to minus 2. What about the order? This is a 1 by 2 matrix. This is a 2 by 1 matrix. Therefore, the product matrix should be a 1 by 1 matrix. Is equal to a 1 by 1 matrix. That is minus 2. Okay. Now, what are the elements? Multiplying the first elements. Minus x into 2x, which is minus 2x square. Y into y. Second elements. Y into y is y square plus y square. These two elements are equal. These two matrices are equal. They are of the same order. Then the corresponding elements are also equal. Which means minus 2x square plus y square is equal to minus 2. This is our equation number 2. We have the first equation and the second equations. These are equations with variables x and y. Okay. Comparing these equations, we can find x and y. Here, I am going to subtract equation 2 from equation 1. What do I get? Equation 1 minus equation 2. First take the left hand side. Here we have x square plus y square minus equation 2. Left hand side we have minus 2x square plus y square. That is equal to. Now the right hand side. Here it is 25 minus. Here we have minus 2. Minus 2. X square minus of minus 2x square. That is x square plus 2x square. Then y square minus y square. Y square minus y square becomes 0. Plus 0 is equal to 25 minus minus 2. 25 plus 2, which is 27. That is x square plus x square is 3x square. That is equal to 27, or x square is equal to 27 divided by 3, which is 9. 27 by 3 is 9. Now check the first question. In the first question, it is given that x and y belongs to whole numbers. Okay. Here when x square is equal to 9, we will be getting x is equal to either plus 3 or minus 3. But we need whole numbers in the first question, which means the value of x will be equal to only positive 3. X is equal to 3. When x is equal to 3, we need to find the value of y. What is y? We can consider this equation. Substitute in place of x, 3. What do we get? Minus 2 into 3 square plus y square is equal to minus 2. Okay. Minus 2 into 3 square. 3 square is 9. 9 into minus 2 is minus 18. Plus y square is equal to minus 2. Which implies y square is equal to minus 2. Taking this minus 18 to the opposite side, we get plus 18. Y square is equal to minus 2 plus 18, that is 16. If y square is equal to 16, the possible values of y are, y can either be plus or minus 4. But we need whole number values. Yes. Therefore, y is equal to 4. The first question, x is equal to 3 and y is equal to 4. Now, the second question, x and y belongs to integers. Integers means we can use the negative values as well. That is, if x square is equal to 9, then the values of x are plus 3 and minus 3. That is, x is equal to plus or minus 3. If y square is equal to 16, then y will be equal to plus or minus 4. So, these are the possible values of x and y when x and y belongs to whole numbers and when x and y belongs to integers. Clear? Next, problem 3, question 5 of exercise 9D. Evaluate cos 45 degree, sin 30 degree, root 2 into cos 0 degree, sin 0 degree into sin 45 degree, cos 90 degree, sin 90 degree, cot 45 degree. Do you remember these values? We have studied trigonometry in detail. Just let us brush up. Here the angles are given and we are going to find the sine, cos, tan, cosec, sec and cot of the different angles. Up to 90 we will be discussing now. First, sine 0. The value of sine 0 is 0. Okay. And cos 90 is also equal to 0. Here sine 0 is 0 and cos 90 is equal to 0. Now cos 0 is 1 and sine 90 degree is 1. Just opposite thing. Okay. Here if it is 0, 90 will be 0. Cos 0 will be the value of sine 90. Now the second, here we have sine 30 degree. If you study sine 30 degree, the value is 1 by 2. Then the same will be cos 60 degree. Cos 60 degree is also 1 by 2. Okay. Sine 60 degree is root 3 by 2. If you study this, same as the value for cos 30 degree. Root 3 by 2. Just the opposite things. Okay. Then we have to study sine of 45 degree, which is 1 by root 2. Sine of 45 degree and cos of 45 degree are the same, 1 by root 2. Okay. If you remember these values, we can find all other values. To get tan, tan is equal to sine by cos. Here we are considering some angles. Tan theta is equal to sine theta by cos theta. Okay. Check this. To find tan 0 degree. Sine 0 by cos 0. Sine 0 is 0, cos 0 is 1. What is 0 by 1? 0 by 1 is 0. Okay. Now, tan 30 degree. How to get tan 30 degree? Sine by cos. 1 by 2 divided by root 3 by 2. 2 and 2 gets cancelled. We will be getting 1 by root 3. Okay. We are just revising the trigonometry concepts. Next, tan 45 degree. To get tan 45 degree, divide sine 45 with cos 45. 1 by root 2 divided by 1 by root 2, which is 1. Next, to get tan 60 degree, root 3 by 2 divided by 1 by 2. 2 and 2 gets cancelled, then we will be getting root 3 by 1, which is root 3. Now, to get tan 90 degree, 1 divided by 0. What is 1 divided by 0? It is a number that is extending to infinity. We don't know the real value. So, we will say not defined. Not defined. Okay. Next, cosec. Cosec is obtained by taking the reciprocal of sine. Cosec theta is equal to 1 by sine theta. Okay. Here what is sine 0? Sine 0 is 0. 1 by 0. What is 1 by 0? Again, not defined. Not defined. Next, cosec 30 degree. How to get cosec 30 degree? We have to take the reciprocal of 1 by 2. 1 divided by 1 by 2, which is 2. Cosec 45 degree, reciprocal of 1 by root 2, which is root 2. Next, 60 degree. Cosec 60 degree, reciprocal of root 3 by 2, which is 2 by root 3. And the last one, reciprocal of 1. Reciprocal of 1 is 1 by 1, 1. Similarly, we can find sec. To find sec, we have to take sec theta is equal to 1 by cos theta. We have all the cos angles value. We can take the reciprocal of them. 1 by 1 is 1. Root 3 by 2. 1 by root 3 by 2 is 2 by root 3. Next, 1 by root 2, it becomes root 2. 1 by 2, reciprocal is 2. Here it is 0. 1 by 0, again not defined. Clear? Now to get cot, either you can find cos by sine or cosec by sec or take the reciprocal of tan. Okay? Cot theta is equal to 1 by tan theta or that is equal to cos theta by sin theta, or that is equal to cosec theta by sec theta. Okay. First, to get cot 0, here we have tan 0 equal to 0. Then what is 1 by 0? 1 by 0 is not defined. Next, 30 degree, cot 30 degree. How to get cot 30 degree? Tan 30 degree is 1 by root 3. Cot 30 degree will be root 3. Reciprocal of 1 is 1. Reciprocal of root 3 is 1 by root 3. Then we have to find cot 90 degree. Reciprocal of not defined. Or we can take cos by sin. Here we have 0 by 1. 0 by 1 is 0. Clear? So these are the angles which we require. Now let's solve this question. Here we have a matrix containing the sine, cos, cot of different angles. Let's find the values. First we have cos 45 degree. What is cos 45 degree? Cos 45 degree, 1 by root 2. Next, sine 30 degree. Sine 30 degree, 1 by 2. Next, root 2 into cos 0 degree. Root 2 into cos 0. Cos 0 is 1. Root 2 into 1, which is root 2. Next, sine 0 degree. Sine 0 degree is 0. We will take this value 0. Next matrix, we need sine 45 degree. Sine 45 degree is 1 by root 2. Cos 90 degree. Cos 90 degree is 0. Sine 90 degree. Sine 90 degree is 1. And cot 45 degree. Where do we have cot 45? Cot 45. This is the value 1. Now we can easily multiply. We know the matrix multiplication. We got the values. So the first element, here we have a 2 by 2 matrix. This is also a 2 by 2 matrix. Multiplying these two matrices, we will be getting a 2 by 2 matrix. Now the elements. First element, to get the first element, considering the first row and the first column of the second matrix. 1 by root 2 into 1 by root 2. 1 by root 2 into 1 by root 2 is 1 by 2. Plus 1 by 2 into 1, that is 1 by 2. To get the second element, considering first row of the first matrix and the second column of the second matrix. 1 by root 2 into 0 is 0. Then 1 by 2 into 1. 1 by 2 into 1 is 1 by 2. To get the third element, root 2 into 1 by root 2. Root 2 into 1 by root 2 is 1. Plus 0 into 1, 0. To get the fourth element, taking the second row of first matrix and the second column of second matrix. Root 2 into 0 is 0. 0 into 1 is 0, plus 0. Okay. Then what are the elements? We will be having the matrix 1 by 2 plus 1 by 2 is 1. 1 by 2, 0 plus 1 by 2 is 1 by 2, which is 0.5. 1 plus 0 is 1. 0 plus 0 is 0. Okay. So this is the required value of the given product of matrices. Okay. Only if you know the values of these trigonometric angles, you can solve these questions. Clear? At least if you know these two, that is, at least if you know the sign, we can put in the reverse order and get what cos is. Sin by cos will give us tan. Taking the reciprocal of sin, cos and tan, we get cosec, sec, cot. At least you have to study these 5. Okay, here we have the next problem. Problem 4, question 7 of exercise 9D. If A341 plus 2B1 minus 2 minus 1 minus 2C is equal to 5073, find the values of A, B and C. Here we have to perform the addition of matrix and then the subtraction. These two parts are equal. we can find the values of A, B and C. Okay. First, let us add these two matrices. We will be getting a matrix. First elements. Here it is A and here it is 2. A plus 2. Okay. A plus 2. Second element, here it is 3 and here it is B. 3 plus B. Third element 4 plus 1. 4 plus 1. Fourth element 1 plus minus 2, that is 1 minus 2. 1 minus 2. Subtracting 1 minus 2 C will give us 5 0 7 3. Okay. That is A plus 2, 3 plus B, 4 plus 1 is 5, 1 minus 2 is minus 1. Subtract 1 minus 2 C. Then you will be getting 5 0 7 3. We will perform the subtraction now. First elements, here it is A plus 2 and here we have 1. That is A plus 2 minus 1. A plus 2 minus 1. Now the second element, here we have 3 plus B, here we have 1. 3 plus B minus 1. Third element, here we have 5 minus 2. 5 plus 2. Minus 1 minus C. Minus 1 minus C. That is equal to 5 0 7 3. Okay. A plus 2 minus 1, that is A plus 1. First element is A plus 1. B plus 3 minus 1. 3 minus 1 is 2 plus B. 2 plus B. Then 5 plus 2. 5 plus 2 is 7. Minus 1 minus C. Minus 1 minus C. That is equal to 5 0 7 3. Now here LHS we have a 2 by 2 matrix. RHS also we have a 2 by 2 matrix. They are equal. Therefore the components, corresponding components or the corresponding elements are also equal. We can equate first element A plus 1 will be equal to 5. Second element 2 plus B will be equal to 0. Third, here we have 7, here also we have 7. Fourth, we have minus 1 minus C will be equal to 3. Okay, if A plus 1 is equal to 5, then what is A? A will be equal to 5 minus 1, that is 4. If 2 plus B is equal to 0, then B will be equal to minus 2. Minus 1 minus C is equal to 3. We can write minus 1, taking this 3 to the opposite side, it becomes minus 3. Minus C taken to the opposite side, we get C. Which means C is equal to minus 4. Minus 1 minus 3 is minus 4. The values are A is equal to 4, B is equal to minus 2 and C is equal to minus 4. Clear? Understood how we determined A, B and C? This is a very easy question. Just we have to add and subtract the elements and then equate to get the values of A, B and C. Next, problem 5, question 10 of exercise 9D. If matrix X is equal to minus 3, 4, 2, minus 3 into matrix 2, minus 2 and 2x minus 3y is equal to 10, minus 8, find the matrix X and Y. Okay, here we have X. X is obtained by multiplying these two matrices. First, let's find what X is. X is equal to minus 3, 4, 2, minus 3 into 2 minus 2. This is a 2 by 2 matrix, 2 rows and 2 columns. What about this? This is a 2 by 1 matrix, 2 rows and 1 column. Okay. Here the number of columns is equal to number of rows in the second matrix, which means the matrix multiplication is possible. What is the order of the new product matrix? 2 by 2 matrix and 2 by 1 matrix. Then the order of the new matrix should be 2 by 1, M by P. Okay, to get the first element, we are considering this first row and this column. Minus 3 into 2. Minus 3 into 2, minus 6. 4 into minus 2, that is minus 8. Okay, to get the second element, second row and this column, 2 into 2 is 4. Minus 3 into minus 2 is plus 6. X is equal to, first element, minus 6 minus 8, which is minus 14. 4 plus 6, 4 plus 6 is 10. So, matrix X, we got matrix X, which is a 2 by 1 matrix. Elements are minus 14 and 10. Now, we will substitute in this place of X. 2 into minus 14, 10, minus 3y is equal to 10 minus 8. Okay. Here, 2 is a scalar and multiplying 2 with this elements of matrix, we will be getting 2 into minus 14 minus 28, 2 into 10, 20, minus 3y is equal to 10 minus 8. Okay. Now taking this minus 3y to the opposite side and this matrix to this side, we get 3y is equal to minus 28, 20 minus, this becomes negative because taken to the opposite side, minus 10 minus 8. That is 3y is equal to minus 28 minus 10. Minus 28 minus 10 is minus 38. Minus 38. Next, 20 minus of minus 8, 20 plus 8, which is 28. Okay, if 3y is equal to minus 38, 28, then what is y? Y will be equal to this divided by 3. Here it is multiplication, opposite side it becomes division. That is, we can take the reciprocal of 3 and multiply with this matrix. 1 by 3 into matrix minus 38, 28. Either you can write like this or you can write as minus 38 by 3, 28 by 3. It is actually not necessary. This is enough. Okay. We got x is equal to minus 14, 10 and y is equal to 1 by 3 matrix minus 38, 28. Clear? Next, problem 6, question 13 of exercise 9D. Evaluate if A is equal to 2, 5, 1, 3 and B is equal to 4 minus 2 minus 1, 3. I is the identity matrix of the same order and A transpose. AT is the transpose of matrix A. Find A transpose B plus BI. You remember what transpose of a matrix is? Here we have a matrix A is equal to 2, 5, 1, 3. How to find the transpose? We have to interchange the rows and columns. First row becomes first column, second row becomes second column. That is A transpose is equal to, here the first row contains 2 and 5. Then the first column will be 2, 5. Okay. Second row 1, 3, that becomes second column 1, 3. Next, we will find A transpose B. To get A transpose B, we have to multiply A transpose matrix and the matrix B. 2, 1, 5, 3 into matrix 4, minus 2, minus 1, 3. Now the normal matrix multiplication we can perform. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. Then the product will also be a 2 by 2 matrix. Now check the elements. First row, first column. 2 into 4, 8. 1 into minus 1, minus 1. Next element, first row, second column. Multiplying 2 into minus 2, minus 4. 1 into 3, 3. plus 3. To get the third element, second row, first column. 5 into 4 is 20. 3 into minus 1, minus 3. To get the fourth element, second row, second column. 5 into minus 2, minus 10. 3 into 3, 9, plus 9. Okay. Now, what are the elements of A transpose B? Is equal to 8 minus 1, 7. Then, minus 4 plus 3. Minus 4 plus 3 is minus 1. 20 minus 3, 17. Minus 10 plus 9, minus 1. We got A transpose B. Now, we will find BI. B is given, which is 4 minus 2 minus 1, 3. And we are considering a 2 by 2 identity matrix. Elements are 1, 0, 0, 1. We have already studied that a matrix into identity matrix will give the same matrix, but still we will perform the multiplication. The elements are first element, first row, first column. 4 into 1, 4. Minus 2 into 0, 0. 4. Next, 4 into 0, 0. Minus 2 into 1, minus 2. Next element, minus 1 into 1, minus 1. Plus 3 into 0, 0. Minus 1. Next element, second row and the second column. Minus 1 into 0, 0. 3 into 1, 3. This is same as the matrix B. Yes, we got B into I equal to 4 minus 2 minus 1, 3. Next, we will find A transpose B plus BI. We have to take the sum of these two matrices. A transpose B is 7 minus 1, 17 minus 1 plus B into identity matrix is 4 minus 2 minus 1, 3. Adding the elements, A transpose B plus BI is equal to, first elements, we will be getting a 2 by 2 matrix, 7 and 4. 7 plus 4. 7 plus 4 is 11. Second, minus 1 minus 2 minus 3. Then 17 plus minus 1, that is 17 minus 1, which is 16. Minus 1 plus 3 is 2. So, these are the elements of A transpose B plus BI. Understood? Next, problem 7, question 15 of exercise 9D. Let A is equal to 4 minus 2, 6 minus 3, B is equal to 0, 2, 1 minus 1 and C is equal to minus 2, 3, 1 minus 1. Find A square minus A plus BC. We have to separately find A square and BC. After that, we can find A square minus A plus BC. How to find A square? A square is A into A. Here A is 4 minus 2, 6 minus 3. Again 4 minus 2, 6 minus 3. Now the matrix multiplication, considering the first row from the first matrix and the first column from the second matrix. We will be getting a 2 by 2 matrix. 4 into 4, 16, minus 2 into 6, minus 12. Okay. Next, second element, we have to consider first row, second column. 4 into minus 2, that is minus 8, minus 2 into minus 3, plus 6. Next, third element, we have to consider second row and the first column. 6 into 4, 6 into 4 is 24. Minus 3 into 6. Minus 3 into 6 is minus 18. Minus 18. Next, the last element, second row, second column. 6 into minus 2. Minus 12. Minus 3 into minus 3. That is plus 9. Plus 9. Now, we will be getting the elements of A square matrix. First element, 16 minus 12. 16 minus 12 is 4. Then, minus 8 plus 6. Minus 8 plus 6 is minus 2. 24 minus 18 is 6. Minus 12 plus 9. Minus 12 plus 9 is minus 3. Okay, this is the matrix A square. Next, we need to find BC. A we already know. We'll find BC. BC is equal to matrix B 0, 2, 1, minus 1 into C. C is minus 2, 3, 1, minus 1. Okay, multiplying first row, first column. 0 into minus 2, that is 0, 10. 2 into 1, 2, plus 2. Next element, first row, second column. 0 into 3 is 0. 2 into minus 1, minus 2. Now the third element, second row, first column. 1 into minus 2 is minus 2. Minus 1 into 1, minus 1. And the fourth element, second row, second column. That is 1 into 3. 1 into 3 is 3. Minus 1 into minus 1, plus 1. We'll be getting the elements of BC. The first element is 0 plus 2, 2. 0 minus 2, minus 2, minus 2 minus 1, minus 3, 3 plus 1, 4. Okay, we got A square is equal to 4 minus 2, 6 minus 3. And BC is equal to 2 minus 2 minus 3, 4. Now we can find A square minus A plus BC. That is equal to, what is A square? 4 minus 2, 6 minus 3. 4 minus 2, 6 minus 3. Next, minus A. Minus A is 4 minus 2, 6 minus 3. Then plus BC. B into C we got, that is 2 minus 2 minus 3, 4. To get the elements of A square minus A plus BC, first here we have 4, considering the first elements. 4, here again 4, then 2. 4 minus 4. 4 minus 4 is 0. 0 plus 2. 0 plus 2 is 2. Minus 2 minus minus 2. Minus 2 plus 2 is 0. Here we have a minus 2. Second element is minus 2. Now the third element, here we have 6. 6 minus 6, 0. 0 plus minus 3, which is minus 3. Now the fourth element, minus 3 minus minus 3. Minus 3 plus 3, which is 0. 0 plus 4. 0 plus 4 is 4. So this is the required matrix. A square minus A plus BC. Got it? 2 minus 2 minus 3, 4. Let's move on to the next problem. Next problem 8, question 18 of exercise 9B. Given A is equal to P002, B is equal to 0 minus Q1, 0 and C is equal to 2 minus 2, 2, 2. And BA is equal to C square. Find the values of P and Q. First, we have to find separately BA and C square. To get BA, we have to multiply matrix B and matrix A. Here matrix B is 0 minus Q, 1, 0. And matrix A is P, 0, 0, 2. The normal multiplication. Considering the first row and the first column from the first and second matrices, we can get the first element. 0 into P is 0, minus Q into 0 is 0. 0 plus 0, 0. To get the second element, considering first row and the second column, 0 into 0 is 0, plus minus Q into 2 is minus 2Q. 0 plus minus 2Q is minus 2Q. Now, the third element, we have to consider the second row, first column. 1 into P is P plus 0 into 0 is 0. Here we get P. To get the last element, we have to take the second row and the second column. 1 into 0 is 0, 0 into 2 is 0. So, we got the elements of matrix B, A. Now, we have to find C square. How to get C square? We have to multiply C matrix with the C matrix. Matrix C is 2 minus 2, 2, 2. Again the same thing, 2 minus 2, 2, 2. Normal matrix multiplication. To get the first element, considering first row and the first column, 2 into 2, 4, minus 2 into 2, minus 4. 4 plus minus 4 is 0. Next element, first row, second column, 2 into minus 2 is minus 4, minus 2 into 2 is minus 4. Minus 4, minus 4, minus 8. Next element, second row, first column, 2 into 2, 4, 2 into 2, 4, 4 plus 4, 8. Next element, second row, second column, 2 into minus 2 is minus 4, 2 into 2 is plus 4, minus 4 plus 4 is 0. We got c square is equal to 0 minus 8, 8, 0. Now we can equate BA is equal to c square. Okay, what is BA? 0 minus 2Q P 0. That is equal to 0 minus 8, 8, 0. Now, considering the corresponding elements, here we have 0, this is also 0. Next, to get Q, we can take the second elements from both these matrices. Minus 2Q will be equal to minus 8. If minus 2Q is equal to minus 8, we can cancel this negative signs. 2Q will be equal to 8, Q will be equal to 8 by 2, which is 4. The value of Q is equal to 4. Now, P will be equal to 8. Here we are considering the third elements. P is equal to 8. Therefore, we got P equal to 8 and Q is equal to 4. Okay? Understood this? Problem number 9. Question 20 of exercise 9D. Here again we have trigonometric functions. Hope you all remember the values of sin 30, cos 30, cos 60, sin 60, etc. At least the basic values you should know. Evaluate 4 sin 30 degree, 2 cos 60 degree, sin 90 degree, 2 cos 0 degree into matrix 4, 5, 5, 4. First we have to find the values for these elements. Here we have the first element is 4 sin 30 degree. 4 into sin 30. What is the value of sin 30? You remember? Sin 0, 0, sin 30, 1 by 2. 1 by 2. Next element, 2 cos 60 degree. Cos 60 degree. What is cos 60 degree? Cos 60 degree and sin 30 degree are of the same value, which is 1 by 2. Next, sin 90 degree. Value of sin 90 degree? Sin 0, 0, sin 90, 1. 1. Then, 2 cos 0 degree. Cos 0, 1. Cos 90, 0. We need cos 0, 2 into 1. Okay. We'll be getting the values. That is 4 into 1 by 2. Cancelling, we get 2. Next, 2 and 2 gets cancelled. Then 1. Here we have 1. 2 into 1, 2. Now this is multiplied with 4, 5, 5, 4. Okay. Here we have 2, 1, 1, 2 multiplied with 4, 5, 5, 4. Normal matrix multiplication considering the first row of the first matrix and the first column of second matrix. That is 2 into 4 plus 1 into 5. 1 into 5. Next element, first row and the second column of second matrix. 2 into 5 plus 1 into 4. Second elements, 1 into 4. To get the next third element, we have to consider the second row of the first matrix, first column of second matrix. 1 into 4 plus 2 into 5. Okay. To get the next last element, we have to consider the second row of first matrix, second column of second matrix. 1 into 5 plus 2 into 4. 2 into 4. Okay. That is 2 into 4 is 8 plus 1 into 5, 5. Next, 2 into 5, 10 plus 1 into 4, 4. Next element, 1 into 4, 4 plus again 2 into 5, 10. 1 into 5, 5 plus 2 into 4, 8. Then what are the elements? 8 plus 5. 8 plus 5 is 13. 10 plus 4, 14. 4 plus 10, again 14. 5 plus 8, 13. 13, 14, 14, 13. Got it? We have simplified this. We have evaluated this matrix into this matrix. First thing, you have to know sin 30, cos 60, cos 0, sin 90 degree. Putting the values, we got another matrix. With this matrix, we are multiplying 4, 5, 5, 4. Then we got the value of the matrix. Clear? Problem number 10, question 23 of exercise 9D. Given matrix A is equal to 4 sin 30 degree, cos 0 degree, cos 0 degree, 4 sin 30 degree. And B is equal to 4, 5. If AX is equal to B, first question, write the order of matrix X. And the second one, find the matrix X. Okay. Here we have matrix A is equal to 4 sin 30 degree, cos 0 degree, cos 0 degree, 4 sin 30 degree. We know the values of sin 30 and cos 0. What is sin 30? Sin 30 degree is equal to 1 by 2. What about cos 0? Cos 0 is 1. Substituting the values, A is equal to 4 into 1 by 2, cos 0, 1. Again cos 0, 1. 4 into sin 30 is 1 by 2. Okay. That is A is equal to 4 into 1 by 2. 2 and 4 can be cancelled. 2 2s are 4. Here we get a 2. Here also we get 2. 2, 1, 1, 2 is the required matrix A. Now it is given that B is equal to 4, 5. Matrix B is equal to 4, 5. And the product of matrix A with a matrix X, unknown matrix X, will give us B. What is A? A is equal to 2, 1, 1, 2. This is a 2 by 2 matrix. Okay. Then we have an unknown matrix X. When multiplied with X, we get another matrix B, which is 4, 5. What is the order of this matrix? Here we have 2 rows and 1 column. This is a 2 by 1 matrix. Okay. We got a 2 by 1 matrix. So we know M by N into N by P gives us M by P. Here in the first question, we need to find the order of matrix X. What is the order of matrix X? What should be the order of matrix X? Matrix X is multiplied with matrix A. Here, number of columns in the first matrix should be equal to the number of rows in second matrix. That is, this n value should be the same. Here we have 2. Therefore, number of rows should be 2. Then, what else? We need the value of P. What is P? In the product matrix, the number of columns is P. Here the value of P is 1. Therefore, number of columns in the second matrix should be 1. Which means X is a 2 by 1 matrix. X is a 2 by 1 matrix. 2 by 2 matrix into 2 by 1 matrix gives us 2 by 1 matrix. Okay. Now the second question. Find the matrix X. We need to find X. Let us take some values for the elements of X. Here in a 2 by 1 matrix, there will be only 2 elements. Yes. This is a 2 by 1 matrix, which means there are 2 rows and 1 column. In the first row, there will be 1 element, and the second row, there will be 1 element. Let us name them as some XY or AB. Here I am taking AB. Okay. Therefore, matrix A, 2, 1, 1, 2 into AB is equal to 4, 5. Next, we will be performing the matrix multiplication. That is a 2 by 2 matrix into a 2 by 1 matrix. First row and this column, what do we get? 2 into A, 2A plus 1 into B, B. Second element, second row and the first column. Here there is only a single column. 1 into A is A plus 2 into B is 2B. That is equal to 4, 5. Now how to find the values of A and B? Here this element from the first matrix will be equal to this element from the second matrix. The corresponding elements should be equal. That is 2A plus B will be equal to 4. Similarly, A plus 2B will be equal to 5. That is second element of this matrix and the second element of this matrix. Okay, we have two linear equations in two variables. We can solve this and find the value of A and B. From the second equation, we can write A is equal to 5 minus 2B. Yes, I am taking this 2B to the opposite side. It becomes 5 minus 2B. Now, this value of A, we can substitute in the first equation. What do we get then? 2 into 5 minus 2B plus B is equal to 4. 2 into 5 minus 2B plus B is equal to 4. Removing the brackets and multiplying 2 into 5, 10 minus 2 into 2B, that is 4B plus B is equal to 4. Minus 4B plus B is minus 3B. Minus 3B is equal to 4. Taking this 10 constant term to the opposite side, plus 10 becomes minus 10. Minus 3B is equal to 4 minus 10 is minus 6. Then B will be equal to minus 6 divided by minus 3. What is minus 6 by minus 3? Negative and negatives can be removed. 6 by 3. 6 by 3 is 2. We got B is equal to 2. If B is equal to 2, then what is A? We have A is equal to 5 minus 2B equal to 5 minus 2 into 2. Value of B is 2. 5 minus 2 into 2, 4, which is equal to 1. That is A is equal to 1 and B is equal to 2. These are the required values of A and B. What are A and B? A and B are the elements of matrix X. Therefore, we can write matrix X is equal to 2 by 1 matrix and with elements 1, 2. Matrix X is equal to 1, 2 are the elements of matrix X. Understood? Okay. Next, last question for today. Problem 11. Question 25 of exercise 9D. Given matrix B is equal to 1, 1, 8, 3. Find the matrix X if X is equal to B square minus 4B. Hence, solve for A and B given X into matrix AB is equal to 550. First, we need to find X. What is X? Given X is equal to B square minus 4B, which means we have to find separately B square and 4B. We have X is equal to B square, B into B. Here B is 1183. 1183 into 1183. Then what do we need? We need 4B. 4B is being subtracted from B square. Minus 4 into B. 1183. Okay. First we'll find B square. We have two matrices, 2 by 2 order. Normal matrix multiplication. Considering first row of the first matrix, first column of the second matrix. What do we get? The first element is 1 into 1, 1. 1 into 8, 8. 1 plus 8. Next element, first row, second column. 1 into 1, 1 plus 1 into 3, 3. Next element, second row, first column. 8 into 1, 8 plus 3 into 8. What is 3 into 8? 24. Correct. 24. To get the last element, what to do? You have to consider the second row and the second column. 8 into 1, 8 plus 3 into 3. 3 into 3 is 9. Okay. Then we have to multiply every elements of B with 4 to get 4B. 4 into 1, 4. Again 4 into 1, 4. 4 into 8 is 32. 4 into 3 is 12. Okay. Now the elements are 1 plus 8, 9. 1 plus 3, 4. 8 plus 24. 8 plus 24 is 32. 32. 8 plus 9, that is 17. Okay. Minus 4, 4, 32, 12. Then what are the elements of X? We have to perform the subtraction, matrix subtraction. We are subtracting this matrix from this matrix. First elements. Here we have 9 and here we have 4. 9 minus 4, that is 5. Second element, considering the second elements of the two matrices. 4 minus 4, which is 0. Next element, we have to take the third elements of both the matrices. 32 minus 32, which is 0. Next, 17 minus 12. 17 minus 12 is 5. 5, 0, 0, 5 are the elements of matrix X. Now, here we have X into AB is equal to 550. X is 5, 0, 0, 5 into AB is equal to, X into AB is equal to 550. Okay, 550. We have to find the values of A and B. We have solved many questions which are similar. Here, we'll multiply this. That is matrix multiplication. Can we perform this multiplication? This is a 2 by 2 matrix. What is the order of this matrix? Here we have 2 rows and 1 column. 2 by 1 matrix. Number of columns in this matrix is equal to the number of rows in the second matrix, which means matrix multiplication can be performed, and we will be getting a product matrix which is of the order M by P. Here M is 2 and P is 1. 2 by 1 matrix. RHS we have a 2 by 1 matrix. Okay. What are the elements? First element 5 into A, 5A plus 0 into B, which is 0. Next element 0 into A, 0 plus 5 into B, 5B. 5A, 5B, here we have 5 and 50. These are of the same order. This is a 2 by 1 matrix, this is a 2 by 1 matrix, given they are equal, which means the corresponding elements should also be equal. Here we have 5A and 5. If 5A is equal to 5, what is A then? A will be equal to 5 divided by 5, that is 1. Then second elements 5B, here we have 5B, here it is 50. 5B is equal to 50, which means B is equal to 50 divided by 5, that is 10. We got the values of A and B. A is equal to 1 and B is equal to 10. Clear? That's all for today. In today's class, we have solved many questions from Matrices chapter, exercise 9D. Hope you all enjoyed this class and solved many problems. There are a few more problems which you can solve on your own. I'll be right back with a new chapter in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.